Okay, good morning, class. So today we're looking at polynomials. Looking at the last exercise, the examples for the last exercise. Okay. Third degree polynomial. Okay. Solving for third degree polynomial equations. In topic 8 you will learn to plot the graph of a cubic or third degree function. You will find the x-intercepts of the graphs. This means you may be able to solve the equation of the type x cubed plus bx squared plus cx plus d. Okay? We are moving into that direction where we can actually, in the previous exercises, we were able to factorize this. Not so. And we know if we set equal to 0, it becomes an equation. And then we can solve for x there. You have seen that the cubic polynomial has 3 factors. Supposed to be a maximum of 3 factors there, because sometimes you'll have 1 factor, sometimes you'll have 2 factors, or 2 factors. One is the x value, and other one with the graph bounds off the axis. We'll see now, which is a 2-in-1 solution there. Okay. A cubic equation will therefore have 3 solutions on the graph, and we will have 3 roots. The cubic equation will always have at least 1 root. The other 2 roots may be real and irrational, or real and irrational. Okay. A cubic equation may have 1 real root if the solution to the quadratic are non-real. Okay, that's what I tried to indicate earlier on. In the graphs below, graph A, you have 3 roots, 3 real roots. Can you see it? In graph A, you have 3 real and 3 real roots where 2 are equal. This is where it bounces off. Can you see it? This is considered as a 2-in-1 root here. Okay, so whenever it works out to be a square or a perfect square trinomial here, then that means to say the graph will bounce off like this. Okay, off the axis at the value where the x is equal to 0 at that point for that factor. In graph B, there are 3 roots, however, they are different roots. Not so. They are also known as distinct. Different means distinct roots. Okay. So what did I say here? Graph B has 3 real unequal roots. Graph C has 3 real roots that all resulting in 1 x-intercept. So they have 3 equal real roots there. And graph D has 1 real root. Roots are where it cuts the x-axis. Not so. And then non-real roots, which means to say it doesn't cut the x-axis there, other than this point. Okay. This is the case where that quadratic that we have calculated can't factorize further. You guys understand? It's going to look like this. Alright, so let's look at example 1. Example 1 is on page 138. Example 1, page 138. And then we're looking at the examples for exercise 5 on page 130. Alright, the question says solve for x and in each case say what type of roots the polynomial has. Okay. So where do we start? Where do we start? We're going to first find the factor, the linear factor, not so. So how do we find the linear factor? We substitute 1. And if 1 doesn't work, negative 1. And then if negative 1 doesn't work, 2. And if negative 2 doesn't work, negative 2. If 2 doesn't work, negative 2. Negative 2 doesn't work, 3. If 3 doesn't work, negative 3, and so on. Okay. So we got answer cubed. Again, I do this so that if the first factor or the second factor doesn't work, I'm not going to punch it in all the time. So time wasting there. So let's press answer, as it's the last answer calculated on the calculator. So it's plus 8. That gives us 8. So is 1 a factor? X minus 1 a factor? No. So I go negative 1. Substitute negative 1 wherever we see answer. Is negative 1 a factor? No. So what do I do now? I try 2. to a factor, x is equal to 2, is that the solution? Yes. So what do I do is I say substitute, x is equal to 2. So I got now 2 cubed minus 2 times 2 squared minus 4 times 2 plus 8 gives an answer of 0. So what do I conclude? Therefore, x minus 2 is a factor. Okay. So what do I write now? I now say that x cubed minus 2x squared minus 4x plus 8 equals 0 is now x minus 2. That's my first linear factor. Alright, so what goes into the quadratic factor? X multiplied by what is x cubed? X squared. 8 divided by negative 2 is negative 4. So what do I add here, people? Kx. Not so. What do I say? I must end off with negative 2x squared. So negative 2x squared is equal to, how do I get an x squared? I multiply a constant with x squared, which gives you negative 2x squared. And a x with an x gives me x squared. Not so. So that's going to give you plus kx squared. But take that over the equal sign, what do I get? 0x squared. So 0 x squared is equal to kx squared. So therefore k is what? K is 0. And what's 0 times x? 0. In other words, that's going to fall away. So I've got x minus 2, x squared minus 4 is equal to 0. So hang on. So try now the quadratic and factorize into what? Difference of 2 squares, which is x minus 2, x plus 2 is equal to 0. So what do you notice now? This could be written as x minus 2 squared into x plus 2. So it's a 2-in-1 solution here. You see that? So which case do you think is going to be here of the 4, sorry? Huh? Anyone? What do you say? Oh, A. So it will be type A. Why? Because that is a 2-in-1 solution. Okay, so you will have 3 real roots where 2 of the roots are equal. Okay, that way basically. So this graph will actually bounce off the x-axis. Okay, it will bounce off where? At x is equal to 2. They asked us what type of graph it is. Okay. Yeah, in each case, what type of roots the polynomial has. So this polynomial will have 3 equal roots, 3 rational roots, where the roots are, where 2 of the roots are equal. Okay. But did I solve for x? No. So before I write this, I should have said, therefore, x is equal to 2, or x is equal to negative 2. Do I have to write 2 twice? No, it's the same thing. You guys understand? So I had to have answered that first, then I would have seen what your roots is. Will you guys understand? It's simple, no? Let's go with example 2. Example 2 is on the same page. So here we are given 2x cubed minus 5x squared minus x plus 6. Where do I start? Sorry? You find the linear factor. How do you find the linear factor? You start with substituting 1. Not so? And if 1 doesn't work? Okay. So I'm going to say 2 answer cubed minus 5 answer squared minus answer plus 6. Right, so we're going to try 1 first. Is 1 a factor? No. So we try negative 1. Is negative 1 a factor? Yes. Not negative. X is equal to negative 1 is the solution. Yes. Okay. We'll substitute. Let's align the board. Sorry about this. Okay, so x is equal to negative 1. So what I do is I say 2 into negative 1 cubed minus 5 times negative 1 squared minus negative 1 plus 6 gives you an answer of 0. So therefore, x plus 1 is a factor. Also, so what do I say now? So 2x cubed minus 5x squared minus x plus 6 equals 0. First, my linear factor is x plus 1. Let's work on the quadratic factor. What goes here? 2x squared. 1 multiplied by what is 6? So what do I add here? Kx squared. 8kx. Okay, so we're going to look for what value of k will result in the second term being negative 5x squared. So what do I say? Negative 5x squared is equal to, how do I get the x squared? Constant by an x squared, which is 2x squared, and an x by an x gives me x squared, which is plus kx squared. Take it over the equal sign, becomes negative 7x squared. It's equal to kx squared. Therefore, k is equal to negative 7. Okay, so we got x plus 1, 2x minus 7x plus 6. Okay, trinomial. Let's check if the trinomial can factorize. So they give you 2 times 2 is 4 plus 3. Yes, it factorizes. You belong there. People, if you can't factorize like this, you just use the formula or the calculator. Okay, so it's going to give you minus minus. You all agree with that? So therefore, if I solve this equation, therefore x is equal to negative 1, or x is equal to 3 over 2, or x is equal to, what would these roots be? How many roots do we have here? How many solutions do we have here? 3. So what can we say? The roots are, you have 3 roots, they are all unequal, and they are rational or irrational? Rational, no? Right? It's like all these numbers can be written as fractions. People, and which type you think this would be? Type B. Why? So you've got 3 different roots there. Okay? Graph could go like that or the other way around. Right. Any confusion there? Any questions? No? Let's look at number 3. Number 3 is also on page 138. Okay, so where do we start? Our linear factor. So we start with x equal to 1. So we put again answer cubed. Answer cubed plus answer squared minus 11 answer minus 3. Okay. I start with x is equal to 1. So is 1 a factor? No. Now I go negative 1. Is negative 1 a factor? No. Let's go with 2 now. Is 2 a solution? No. Now I go negative 2. It's not going to work because I have this 3 here. Okay, but there's a lot of rules around that. So we make like we don't know. Okay. So we go minus q, it doesn't work. So now I try 3. Does 3 work? Yes. So which means to say x equal to 3 is actually a root of the equation or a solution. So what I do is, I say, we're going to substitute x is equal to 3. So you got 3 cubed plus 3 squared minus 11 times 3 minus 3. And they gave me an answer of 0. So I conclude. Therefore, x minus 3 is a factor. Alright. So what do we get now? X cubed plus x squared minus 11x minus 3 is equal to 0. My linear factor is x minus 3. So as x multiplied, what is x cubed? X squared. Negative 3 times what is negative 3? Positive 1. So what must be added here? Okay. So what must it be equal to? X squared. So I say x squared is equal to, how do I get x squared? A constant by x squared, which is negative 3x squared. And then x by and x will be positive kx squared. To get over the equal sign becomes 4x squared is equal to kx squared. Therefore k is equal to 4. It's easy, no? So x minus 3 x squared plus 4x plus 1 is equal to 0. Hang on, that can't factorize. Not so. So what do? I use the quadratic equation. So x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. That's the formula we're going to use here. So it's negative 4 plus minus the square root of 4 squared minus 4. Your a value is 1. Your b value, your c value is 1 over 2. And your a value is of course 1. So it's minus 4 plus minus. That's 16 minus 4 is 12. 12 is 4 root. The root of 12 over 2, which is also negative 4 plus minus. 4 is 2 root 3 over 2, which is negative 2. So it's negative 2 plus minus square root of 4. So how many roots does this equation have? How many roots are here? By minus 2 plus minus 3. 2. Is negative 2 plus 3, root 3, and negative 2 minus root 3. There's 2 here, and there's 1 here. So what can we say about the nature of these roots? They are how many roots? 3 distinct or 3 different roots. Not so. Where 1 is quadratic, not quadratic, the cube, rational, and 2 are irrational. So which example, which type would that be? This would be, again, B. Why? So it's 3 roots. It's going to cut your axis at 3 different places. Does it make sense? Okay. And then of course the last one, example 4. It brings this chapter to a close from my side. Right, so where do we start? We got x cubed plus 2x squared minus 3x minus 10. Where do we start? Substitute. Substitute. 1. So you got answer cubed. Answer cubed. Plus 2 times answer squared. Minus 3 answer minus 10. You're going to substitute 1 in first. Is 1 a factor? No. So let's go. Minus 1. Negative 1. Negative 1 a factor? No. Now we go 2. Is 2 a factor? X is equal to 2 a solution? Yes. What do we say? We're going to substitute x is equal to 2. We get 2 cubed plus 2 times 2 squared minus 3 times 2 minus 10 gives us 0. So therefore, x minus 2 is a factor. So we got x cubed plus 2x squared minus 3x minus 10 equals 0. So I have x minus 2. So x times what is x cubed? X squared. Negative 2 times what is negative 10? 1. So what do I add here? X. So what must it equate to? 2x squared. So how do we get x squared? It's negative 2 times x squared is negative 2x squared. And then x times x, so it's going to be positive kx squared. We get over the equal sign becomes 4x squared is equal to kx squared. Therefore, k is equal to 4. So now this means x minus 2. X squared minus plus 4x plus 5. Okay, not k but x. No? Again, that can't factorize. Well, because I must add my factors. Okay, that must either be 6 or minus 6. So what do I do here? I use again the quadratic formula. So x is equal to 2 or x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. Which gives us negative 4 plus minus the square root of, that is 16 minus 20, which is negative 4 over 2. So hang on. What's going to happen there? Imaginary roots, no? Now not real roots here. So no solution on this one. So that means to say what? If we only have one rational root. Okay? You guys understand? And what type would this be? Would it be D? Why? Because this is three equal roots here. Not so. That is what it's going to look like. However, this graph has one rational root. Okay, people, for a cubic function there will be at least one rational root. Okay. People, any confusion there? Now, with that you should be able to do exercise 5. Yes?